Hydraulic fracturing, more commonly known as fracking, is a process which allows natural gas to be extracted. Fracking has proven itself to be helpful in alleviating some dependence on the importation of foreign fuels and is a stepping stone toward new technologies and energy independence for the United States. Until recently, pockets of natural gas have been lying approximately 1.5 miles beneath the surface of U.S. soil. Fracking allows us to recover this resource and bring relief to the ever-growing energy crisis facing the U.S. The fracking process has been used or is currently being used in a number of states. The process begins with drilling a borehole into the earth to a depth of approximately 1.5 miles, or about 7,700 feet below the surface. Safety is a top priority, and precautionary measures are in place surrounding the borehole, such as protective steel casing, as well as additional cement casing at groundwater levels. To help visualize the extreme depths at which extraction occurs, imagine you are standing on the observation deck of the Sears Tower, now known as the Willis Tower in Chicago, Illinois, and you are looking down to the streets below. Now imagine 5 of the Willis Towers stacked on top of each other and looking downward from that distance. 5 Willis Towers stacked vertically are the equivalent of 7,700 feet, the approximate depth at which extraction occurs. One of the main concerns voiced by those opposing fracking is the potential to contaminate the underground water supply. Preservation of groundwater quality is the first priority in the fracking process, and this is addressed by placing additional steel and cement casings around the borehole to prevent leaks in the aquifer. As the borehole is drilled into the ground, it passes through many different layers of earth and several thousand feet of solid rock layers. These rock layers, such as granite for example, are extremely dense and therefore not affected during the fracking process. The density of those layers acts as a natural barrier between the shale layer where the extraction occurs and the groundwater level, and thereby will prevent any natural gas or chemicals from seeping into the groundwater supply. Once the borehole has drilled down to the shale layer, perforating tools are then guided down the borehole carrying conductors. Once these tools are in place, the conductors emit a shock wave into the shale layer. This shock wave causes slight underground fractures in the shale layer. These fractures are also known as fissures. Once the fissures are created, the perforating tools are removed and brought to the surface. Water and sand are then blended with additives in preparation for insertion into the borehole. This mixture is made up of over 99% water and sand, and less than 1% other additives. The water and sand mixture, or proppant, is injected into the borehole and travels down the depth of the borehole into the shale layer. The pressure caused by the water mixture allows the fissures to expand. Most of the water mixture is extracted and stored in a storage reservoir. However, a small amount of proppant is left behind, which consists mainly of sand. These small particles help the fissures to remain open. The open fissures make it easier for the natural gas to be extracted and flow towards the surface. The natural gas is collected in reservoirs, then pumped into container trucks and hauled away from the fracking drill site. The water and sand mixture is combined with a very small portion of chemical additives. These other additives make up less than 1% of the mixture. These additives can be found in products we use every day, such as laundry detergents and soaps, household plastics, deodorant, disinfectants, cosmetics, acrylic fibers, and food additives. Fracking provides a valuable energy source for the United States. Natural gas is a clean fossil fuel. Using natural gas as an energy source in lieu of other energy sources, such as coal for example, will reduce carbon dioxide emissions by 17% and thus lead the United States towards a carbon-light environment. Moreover, the abundance of natural gas on U.S. soil will not only support America's energy needs for a longer period of time than other fossil fuels, it will also create jobs, stimulate the economy, and enable the United States to produce its own energy supply that in turn reduces our need to rely on foreign fuel imports. Extracting natural gas by fracking provides enormous benefits with minimal risks. It lowers energy costs and benefits the environment. The potential risks involved in fracking are minimal and are easily managed. As we have seen here, groundwater is protected by thick steel tubing and cement casing, and fracking occurs miles away from drinking water. New technologies and processes continue to ensure that safety is a top priority. As of today, current U.S. oil reserves are limited and can only sustain the energy needs of Americans for the next 9 years, which leads to a heavy reliance of foreign fuel imports. However, fracking will produce enough natural gas to sustain the energy needs of Americans for the next 100 years, bridging the gap and providing a sustainable energy resource while research continues and new technologies for additional alternative energy resources can be developed. Leveraging domestic energy resources is smart policy for our country and provides the United States with the ability to be more self-sustaining. Since natural gas is an abundant resource right here on American soil, fracking provides an opportunity to lessen our dependence on foreign energy and increase energy innovation and revenue within the U.S.